Hello students and welcome to week 3 of JSS1 second term mathematics. I hope you enjoyed all we had to do in week 1 and in week 2. I trust that you've learned a lot from those videos, and please do not forget that if you do have any question at all concerning the topics in those videos or any other of our videos, feel free to drop your questions in our comment box and we will attend to all of your comments. And as you already do know, this is Oyalearn, your flawless school tool, where we give you academic videos like this to help you level up and be an expert at the various topics you should be taught in your classroom. Okay, now please ensure that you share this video amongst your friends so that you too can help them get better and make the academic journey a lot more smoother. All right, and you can do this by sharing the video and encouraging your friends to engage with our videos, dropping a like, asking questions in the comment section, and together we are building a community of great learners. Thank you all so much for doing that. All right, so in week 3, what we're going to be looking at is simplifying algebraic expressions. Okay, now algebra is an aspect of mathematics that deals with working with or trying to solve for unknown numbers. Okay, we've looked at open sentences where we discovered that you can continue to test with different numbers until only one particular number makes such open sentences to be true, right? So, and we also learned to substitute for those signs, those symbols. We changed them and used letters in that place. So when you have such kind of sentences where you have open sentences with letters representing symbols, what you have is an algebraic expression. So today we'll be learning how to simplify algebraic expressions. And as part of what we are learning today, I will be touching these various areas because we believe by the end of this video, you should be able to do all of these that we have itemized here. Firstly, you should be able to identify and state the coefficient of an algebraic term. Now, in algebraic terms, there's something called coefficients. We'll learn what those coefficients are and how to identify them and also state the coefficient of a given algebraic term. Aside that, we'll also learn to perform basic arithmetic operations such as addition, subtraction, multiplications, and divisions on algebraic expressions having similar terms. That is, when they have similar unknown terms, perhaps you're solving for x, you're simplifying for x, simplifying for y, simplifying for a, b, c, or any letter at all. Now, please do know that the letters are not limited to the English alphabet. We also use letters and symbols from other alphabets, like the Greek alphabet, for example. You could find things like alpha, gamma, theta, pico, and so on like that. So many of them. You could find a lot of them. Whenever you have letters or symbols, we'll learn how to perform basic arithmetic operations with those similar terms. They have to be similar in this particular vein. But it's not limited to that. You could also have some algebraic terms that have dissimilar terms. I'm saying you have A, B, C in the same algebraic term. And that will be the third thing we'll be doing, where we'll learn to collect like and unlike terms. So when they have similar terms, we collect them. When they have unlike terms, we collect them and then go on to simplify whatever we have in the end of that. So many algebraic expressions you will find will have a combination of multiple letters scattered across in different ways. Now, it is the job of anyone who is simplifying them to first arrange them in a neat order. It's just sort of what happens when you're told to clean up your room. Right? So when you go to your room, you find your books, you find your clothes, all of them scattered across the entire room. What you want to do is to select them and group them. So clothes go to one path, those that has to go into your wardrobe goes there, those that have to go to the laundry basket go there. You sort them. That's for your clothes. Then you sort your books, put them on the shelf. You sort for other materials and keep them where they ought to be. So we'll be learning how to arrange our stuff like cleaning the room with algebraic expressions at this level. And then when we are done with everything, you too should be able to do a lot of all these activities with different algebraic terms. You'll find a lot of them in your textbooks and past questions and other things like that. And of course, like we always say here, practice gets you a lot more better. So when we solve these problems, you too can also practice with other questions around you, and feel free to let us know how the journey is going. You can always do that by dropping a comment in the comment box. Thank you all so much for that. So now that we've identified what we're going to be doing in this video, you know the scope now, so let's just get to it and begin to simplify algebraic expressions. Before we go into identifying the coefficients of algebraic term, the question we need to ask ourselves at this point is, what exactly are the coefficients of algebraic terms? Okay, now in algebra, we often term items that we don't know with alphabets. We replace them with alphabets. In mathematics, we say we substitute them with alphabets. So for example, if we are dealing with apples that we don't know how many they are, we say let the number of apples be X. Or we say let the number of oranges be Y. Or we say let the number of bananas be Z. All of these are algebraic terms. Okay, so if I have one apple, that is 1x. Now if I go on to have two apples, then that makes it what? 2x. Are you getting me now? So if a certain box of apples have the same number of apples in them, so once I get multiple of such boxes, I have a certain number of x box of apples. You understand what I'm saying now, right? So if a person has a box of apples, that's just one box. If you get another one to that, it becomes 2 box. Now you can change the box in that statement to an alphabet, a letter rather, and you can say let box be B, for example. So one box will be 1B. 2 boxes will be what? 2B. 3 boxes, 3B. That's basically what coefficients are. They are those numbers that let you know how many of such variables do you have. So you have something that the number can change with time, okay? So you identify how many of such you have with a number. Now the number can be positive, it can be negative, it can be even fractions, okay? So that number attached to a unknown variable is what is called the coefficient of that variable. For those of you who watch cartoons a lot, you might have seen something like this, where a certain person is standing at a location, then something happens and the person just moves away from that spot. He moves away so fast, and how they identify the person has moved is you see the outline of the person's shape there, showing that something ought to be there that is now missing. That's like saying the person has been deducted from that frame. That's a negative coefficient. It's as simple as that, okay? So when you have an algebraic term, say x, this is just one of it. So since it is 1, the coefficient is what? 1. Coefficient is 1. Now if I get 5 of this, that will be x plus x plus x plus x plus x. Let's count together. 1, 2, 3, 4, 5. So how many x do I have on this line? I have 5x. So that makes it what? 5 and x. And in this case, the coefficient is what? Coefficient is 5. Okay? Now, when you have negative coefficients, it means that certain number of those are unknown is missing. So for example, if I need 10 more x to complete the number of x I need, something is missing then. And what is missing there? Altogether here, how many do we have? This is 5, this is 1, and we have 6 in total, right? And I need to make up 10. It means 4 x's are missing, so I have negative 4x. So in that case, the coefficient will be what? Negative 4. And don't forget, you could also have fractions as the coefficients of an algebraic term. So what we're going to do next is, I'll write some algebraic terms on the board, and then we'll find out how you can identify the coefficients for those algebraic terms. On the board, we have 6 algebraic terms, and we are going to identify the coefficients of these terms. Now, one simple way to identify the coefficient of an algebraic term is to determine the number that is multiplied with that term. Okay, and you can do that by decomposition. Now, what does this mean? When we take a look at the first term we have here, we have 5x. So what number multiplies with 5 here? Okay, 5 multiplied by x will give you 5x. So when we decompose this, it will be 5 multiplied by x. Okay, so this number is what multiplies with x to give 5x. So the coefficient is 5. It's a positive number. Okay, and in the second one here, we see that negative 3 multiplies with y. So negative 3 multiplied by y gives minus 3y. So that makes the coefficient what? Yeah, you got it right. That is minus 3. Now, when you look at this, you see 1 over 2, that's half, multiplied by x. So we can write it as half multiplied by x. Okay, and that is half of x. So that means the coefficient must be this fraction here now, not just 1. It is the entire fraction that multiplies with x. So that makes the coefficient half. Now, when we look at this, students are often confused as there is no number here. But when we try to decompose this, we see that something must multiply with a to give you minus a. And the only thing that can multiply with a to give you minus a is minus 1. So we say minus 1 multiplied by a. The same thing applies if I just have a standing on its own without the negative sign. In that case, there will be no negative sign here. It would have just been 1 times a. Okay? Now, some people just say once you see a letter standing on its own, it means the coefficient is an invisible one. It's not invisible. Sometimes we just don't write it in mathematics. Okay? So negative 1 multiplied by a gives you negative a. It shows that the 1 is not there, but it is actually there because 1 times anything remains that particular thing. Okay? So what we have here makes the coefficient negative 1. And then when you look at this, the coefficient will be what? First, let's decompose. So we'll be having negative 2 over 3, that is negative 2 third, multiplied by b. So that means the coefficient is what? Negative 2 third. Okay? And what do we have here? What do you multiply with c here? You see that it is what? It's not just over 5, it is 1 over 5. So 1 over 5, that's 1/5 of c. 1 over 5 multiplied by c. And that makes the coefficient 1 over 5. Okay? Now, I want you to determine the coefficient of the following algebraic term. And then, do the same thing for put the coefficients of these algebraic terms in the comment section. Now we're going to be performing some basic operations on expressions with similar terms. But before we dive straight into that, here are a few things that I believe that when you do know them, it helps you perform these basic operations faster and without error. Now, the first thing you need to know is what we have already discussed before, and where you have something like 5x. What this simply means is that you have x plus x plus x plus x plus x. Okay? And similarly, when you have, say, 2x plus 3x, what does this mean? It means here we have x plus x. Now, we add that to this one, which is what? X plus x plus x. Now, when you add all of this together, how many x do you find here? You see 1, 2, 3, 4, 5. So we call that 5x. So when you have 2x plus 3x, all you need to do without going through this route is just add the 2 and the 3 together and then multiply them by x. So you get 5x straight away, okay, without having to go through this route. Another thing that is very important that you understand when it comes to dealing with this kind of similar terms is that sometimes you also get negative terms. Say, for example, minus 4x. This means instead of the x plus x, it's now minus x minus x minus x minus x. This is what gives you, because this is minus 1x, minus 1x, minus 1x, minus 1x. So minus 1, minus 1, minus 1, minus 1 gives you the minus 4 and then the x. Okay, so this is why when you have something like this, take a look at this. If you have x minus x, your answer is what? 0, because this is plus x minus x, you get 0. So similarly, if I have, say, 3x minus 2x, what does this mean? Here I have x plus x plus x. And then here I have minus x minus x. Now let's group them so that they look like this. I can take one of this and say x minus x, then plus x minus x. I've taken the 2 here, so I'm left with plus x. Now, what do we have here? This is 0 plus x, which gives you x. So I can just say 3 minus 2, and that gives me 1. So 1x is x. I hope you understand what this is. Okay? Another thing you need to understand is that you can also result in negative terms. For example, if I have, say, 2x minus 3x. Now, simplifying this means I have x plus x, and then here I have minus x minus x minus x. Now, this gives me 0. This gives me another 0, leaving me with what? Minus x. Hence, 2x minus 3x is minus x. So how do you do that? The same way you deal with numbers when you are performing basic operations on them. 2 minus 3 gives you negative 1. Remember that, right? The same thing applies to algebraic terms. And all of these are also done when you have multiplication. But some things that you need to know when it comes to multiplication is this. Sometimes even if they don't have similar terms, it could work. But here we are working with just similar terms, so let's limit it to that for now. So if I have, say, 2c multiplied by 3. My answer does not stop here. This would mean I have 2 multiplied by 3, which will give me 6, and then c. Okay? It means I have 2c in 3 places, and let's try to do that. What is 2c? It means 2c plus 2c plus 2c. 2c in 3 places. Can you see that? And this is how we get the 6c. It's as simple as that. The same thing applies to division. So if I have, say, 10b divided by 2, okay, it means I will group 10 b's into 2 places. This is b plus b plus b plus b plus b plus b. How many do we have so far? That is 6. So we need 4 more. Plus b plus b plus b and plus b. Now let's group them in 2. Look at this. 2 b's, 2 b's, 2 b's, 2 b's, and 2 b's. Now what does this mean? 1, 2, 3, 4, 5. It gives us 5b in the end. And 10 divided by 2 will always give you 5 as well. So sometimes when you deal with things like this, you don't have to go through the long route of first simplifying each of them and then solving. There are these simple tricks that help you do them a lot faster. Once again, so you don't forget, don't ever forget that 5x simply means you have x in 5 places added to each other. And when you have 2x plus 3x, instead of breaking them down and then counting how many you have, you can just add these 2 and 3 together, and that gives you 5x in total, which is the same thing you would have gotten if you have gone through the longer route. Okay? You can also have negative terms, which means you have negative x in 4 places like you have here, minus 4. Negative x in 4 places gives you the negative 4. And when you have a positive term and a negative term with the same coefficient side by side, that gives you a 0. So when you have x minus x, that's 0. Similarly, 5x minus 5x is also 0. 20x minus 20x is also 0. It always works all the time. Positive and negative of the same coefficient ends up in a 0. Okay? And then you can always subtract a certain term from another. All you need to do is look at the coefficients, subtract them from each other, and then you are left with your answer without having to go through all this long route. And sometimes you end up with negative value like what we see here, And when you multiply, just multiply the coefficients or the numbers alone and you get the same answer. And the same thing applies to division. Now let's take a look at some questions and apply this knowledge to solving or simplifying algebraic expression by performing basic operations on them, such as addition, subtraction, multiplication, and division. We have 3 algebraic expressions here that we are to simplify. Do not forget all that we've learned so far as to simplifying or performing basic operations on expressions like this. Okay, another thing you observe from the expressions we have here is that they are all similar terms. They are all in terms of x here, and here we have all of them in terms of AB, and here they are all in terms of A. Okay, so when you have similar terms, you can always perform the same basic operations with them, especially when it comes to addition and subtraction. But when it comes to different terms, you cannot add or subtract terms that are not similar, but you can multiply or divide terms that are not similar. Okay, so when we start getting to unlike terms, I will show you what I mean by that anyways. But for now, let's look at adding all these similar terms together. Okay, remember that you could go the long route and say how many of these you have. That's x in 2 places. This is just 1x and this is 4x, and then you begin to add all the x you have all together. But instead of doing that, I've already shown you that you can just add their coefficients together and then you name it by this term. So let's see what that would look like. So in this case, solution, when we have 2x plus x plus 4x is the same thing as saying 2 plus 1 plus 4, which is all the coefficients here, and all of them multiplied by x. So 2 plus 1, that gives us 3, plus 4, and then we have 7. So what we have now is 7x. And that's how you simplify something like this. Or you could just simply go 2 plus 1 plus 4, and then you name it 7 and then x. Okay, let's apply the same thing to this other question where we have 3ab plus 2ab plus ab plus 5ab. So we are going to add all the coefficients. So the coefficient here is what? 3, plus the coefficient here is what? 2, plus the coefficient here is what? 1, plus the coefficient here is 5, because it's only 1 that multiplies AB to give you AB. So here, what do we have? All of these are terms of AB. So 3 plus 2 gives us 5, plus 1, and then we have 6, plus 5, and then we have 11AB. Now, what happens in this case? We have half A plus 1/3 of A. Now, the coefficient here is what? Half. Plus the coefficient here is 1/3. All of these are terms of A. Now, do you remember how to add fractions that do not have the same denominator? If you don't remember, please check out our videos where we talked about fractions in more details and you'll come to the understanding. But let me show you how this is done. When you have different denominators like this, you draw your divisor line and then you take LCM of 2 and 3 and that will give you 6. So when the LCM is a multiple of 2 and 3, it's easy. I can just say 3 times 1 plus 2 times 1. Another way to go is to say 6 divided by 2 and that will give you 3. 3 multiplied by 1 and that is 3. Plus 6 divided by 3, that gives 2. 2 times 1 and that's 2. All of these are still terms of A. Now 3 plus 2, that gives you 5 over 6 of A. Okay? And that is how you simplify algebraic terms like this. Here is another set of algebraic terms that we're going to simplify. So one thing that you need to do with terms like this, you see we have positives, we have negatives all mixed up together. So what you need to do is to recall our lesson on the order of mathematical operations. And what is that order? We have brackets, other. In some other kind of explanation, you might see it instead of O having E. Okay, and that is for exponents. Then we have D, which stands for what? Division. We have M, which stands for multiplication. We have A, which stands for addition. And then S, which is subtraction. So when it comes to mathematical operations, we have to rank them. Brackets take more precedence, or they take more importance. That is, we always solve for brackets first before we begin to solve for others. That is when you have a fraction of something. Okay, that's when this comes in. Then division comes next in line amongst the hierarchy, amongst who is more important when it comes to mathematical operations. Then we have multiplications, followed by addition, and then finally subtraction. Okay, so the same thing applies to when you are solving problems like this. So what do? Let's take a look. Solution. Now the question itself says 4b minus 5b plus 3b. So what do? Remember, we always take the coefficients. Let's put the coefficients together. Now we have 4 minus 5 plus 3, and all of these are terms of b. What does this mean? What is here? We have to rearrange them. And remember, addition comes before subtraction in this hierarchy, right? So we're going to say 4 plus 3, then minus 5, all terms of b. 4 plus 3, that gives you 7, minus 5 as terms of b, and 7 minus 5 will give you 2, so 2b. Another way to do that is say 4 plus 3, 7 minus 5, 2. However, if you go this straight line, you will still get the same thing, because 4 minus 5 is minus 1, and minus 1 plus 3 is plus 2. Okay, so but it's a lot more easier to just arrange it first before you solve. Okay, now let's get to the second one here. Now we have minus 3c plus 8c minus 2c. Now we have two negative values here. So what do? Of course, we're going to arrange them. So we have minus 3 plus 8 minus 2, all terms of c. And when we arrange, we have 8 minus 3 minus 2, all terms of c. Now 8 minus 3 would give me, that is 5 minus 2, terms of c. And 5 minus 2 will give you, yes, 3c. Now please take note. Minus 3 minus 2 will give you minus 5. I've shown you something like that earlier before we started all this basic operation. And so minus 3 minus 2 is minus 5. And 8 minus 5 is still plus 3 as we have here. Okay, I just believe that when you arrange them like this, it becomes a lot more simpler for everyone to get it. And since our goal is to make sure that everyone understands, that's why we're doing it the simplest way possible. Now to the final one. We have 3a's divided by 4 minus 1 over 4 of a. So these are fractions. So what do? We group them, we take the coefficients. So we have 3 over 4 minus 1 over 4. Those are the coefficients, and they are all terms of a. We can do this because they are the same term, they are similar terms. Okay, so now when we have fractions with the same denominator, what do? We just maintain the denominator and then perform the arithmetic operation on just the numerator. So now we have 3 minus 1. All of these are terms of a, which gives you 2 over 4 of a. But this is not the fraction in its lowest term. Remember, we did learn during fractions that whenever you have a fraction and it's not in its lowest term, it is advisable to break it down to an equivalent fraction of that in the lowest possible term. And here we see that the numerator and denominator are both divisible by 2, so we divide them by 2. 2 goes here once, while 2 goes here twice, leaving us with 1 over 2 of a. And that's the solution to these expressions. Before we go on to solve this particular one on the board, before we simplify the expression, there's something I need to show you first. Now, when you look here, we see ABC, BAC, CAB. What does that mean? See, there's something about multiplication. They have what we call associative rules. Now, when you look at something like this, A times B times C is the same thing as B times A times C, which is also the same thing as C times A times B. It doesn't matter how you arrange them. They all give you the same answer, which is ABC. So that means ABC is the same thing as BAC, which is the same thing as CAB, which is the same thing as BCA, no matter how you want to arrange them. Okay? So the same thing applies here. So what I'm going to do first is write them so that they look alike, so that they don't confuse me any longer. So in my solution, what I will do is this. This is ABC plus, this is BAC. I'll write it also in this term because they have the same thing, A, B, and C. A, B, and C. So I'll write and say ABC as well. Okay? Now this will be what? Plus 2ABC, then minus, this is CA and B, which is the same thing as ABC. So ABC, then plus 2ABC. And of course, we're going to rearrange them when we write the coefficients. So this is 1 plus 1 plus 2 minus 1 plus 2. All are terms of A, B, and C. Now, when you rearrange, you have 1 plus 1 plus 2 plus 2, then minus 1, A, B, C. 1 plus 1, that's 2. Plus 2, we have 4. Plus 2, we have 6. Minus 1, and then we are left with 5, A, B, C. It's just as simple as that. I hope you get it, right? All right. Now, let's go to the next one, the B part. What do we have there? We have 5 multiplied by 2x. Then we're going to add that to 2 multiplied by 3x. Then we subtract 4 multiplied by 2x from everything. Okay, now multiplication takes more importance than addition or subtraction according to BODMAS. So what do? We're going to do all the multiplications first. And then 5 multiplied by 2x would give us what? 5 times 2, that is 10x. And then 2 multiplied by 3x would give us what? 6x. And then here we have 4 multiplied by 2x, which will give us 8x. Now we arrange. So here we have 10x plus 6x, then minus 8x. That means we have 10 plus 6 minus 8, all as terms of x. 10 plus 6 is 16 minus 8, and we are left with 8x as the simplest term of all that we have here. And that's how we simplify expressions like this. Don't forget, if you do have any question at any point, you can always drop them in the comment section. I look forward to your own question. Here is another question, and we're going to simplify them. So let's start with the very first one here, where we have 45p divided by 5p. Solution. (45p) divided by 5p. So as we've done as with the other questions that we simplified, we're going to work with the coefficients. So here we have 45 divided by 5, and they are terms of p. 45 divided by 5 goes in 45 in 9 places. So that gives us 9p. Interesting, right? Good. Now let's get to the next one. Now we have 2/3 of m, 3/8 of m, all multiplied by 5m. Okay, so what do? We work with the coefficients. So 2/3 multiplied by 3/8 multiplied by 5. All of these are terms of m. Okay, now this means we have 2 times 3, which is 6. 6 times 5, and that gives us 30, divided by 3 times 8, and that is 24 of m. Now look at this. What's the highest common factor of 30, and 24. Okay? The highest common factor is definitely 6. 6 goes here how many times? 5 times. Why 6 goes here 8 times? Oh, 6 goes here 4 times, I mean. So now we have 5 over 4 m. Now when you work with this, we can rewrite it as a mixed fraction if you like, but you could also leave it as this. So if I were to leave this as a mixed fraction, that would be 4 goes in 5, 1. 1 time, remember 1, so 1 over 4. So 1 whole number 1/4 of m being the solution. But this looks better, so I prefer this as the simplest term for this algebraic expression. And then to the final one here, we have 1/3 of y divided by 2/3 of y. So when we deal with the coefficients, we have 1 over 3 divided by 2 over 3. And for those who are very conversant with how we work with divisions of fraction, what do? I will change this to multiplication and then flip the other fraction. So now we have 1 over 3 multiplied by 3 over 2. All of these terms of y. So you can then say 1 times 3, that's 3, divided by 3 times 2, and that's 6y. And of course, 3 goes here once, while 3 goes here twice. So our final answer is half y. Okay, so in this case, we have 9p. Here we have 5 over 4 of m, and here we have half of y as the simplest term of these 3 algebraic expressions. Now that we can add and subtract algebraic expressions in similar terms, we can even multiply them with whole numbers and things like that. But what happens when you have similar terms multiplying each other or similar terms adding to each other? There's a complete different thing that goes on in that world. So, for example, if you have a multiplied by a, it is different from a plus a. A plus a will give you 2a. But in this case, we are having a multiplied by itself twice, a times a. So this is often written as an exponent, where you now say a multiplied by itself, how many times? Twice, so that is a to the power of 2. The same thing applies to when you have a times a times a. Now this is a multiplied by itself, how many times? 1, 2, 3, so this is a cubed. Okay? And then when it comes to the place of division, now if you have this, say a times a times a divided by a times a. Okay? What does this mean? This means that how many of these at the denominator can you find here? Now this is one group here, leaving you with just this here. Okay, a times a times a, that leaves you with just a here. So this is once also. The final answer becomes a. Okay, another way to think of it is in this particular sense. Look at a times a times a, all divided by a times a. Now a goes here once, a goes here once, a goes here once, a goes here once. So now we have 1 times 1 times a, that gives you a here, divided by 1 times 1, which is 1, and your answer is still a. Okay, so whenever you have similar algebraic terms multiplying into each other, always remember that the number of times they multiply each other would give you the power that you have. So you often write such in exponents. But sometimes it could be accompanied by numbers. Say for example, 2a multiplied by 4a. Now, if this were addition, it would have just been 6a. But since it's multiplication, you first go 2 multiplied by 4, then a multiplied by a. 2 multiplied by 4 will give you 8, and a multiplied by a will give you a squared. And the same thing applies when you have, say, 3a divided by 9a. Now, when you look at this, it means 3a all over 9a. A goes here once, a goes here once. So you are left with 3 over 9, which when you write in its lowest term, you will have 1 over 3. So you have to be very careful when working with similar terms like this, and then you are multiplying or subtracting them. So let's take a look at some examples of questions like this and apply this knowledge to multiplication and division of algebraic expressions with similar terms. Simplify. A. 3y multiplied by 2y multiplied by 1/6 of y. Solution. We have 3y multiplied by 2y multiplied by 1/6 of y. And as we did when it comes to addition part 2, we also have to deal with the coefficients. So this will be 3 multiplied by 2 multiplied by 1/6. All of this, then we have to now multiply the terms themselves. So y multiplied by y multiplied by y. So what does this mean? 2 times 3 is 6 times 1, we have 6/6. Multiplied by y times y times y. This gives you y. How many times? 1, 2, 3. So you put that as a power. Y to the power of 3. And 6 divided by 6 will give you 1. So 1y cubed, or just basically y cubed. Now what happens to the B part here? We have 45a divided by 5a. We can write this and say 45a all over 5a. And you easily see that a goes here once, a goes here once as well. And 5 goes here once, 5 goes here 9 times. So what do we have left? This is now 9 times 1 divided by 1 times 1. So we have 9 divided by 1. And what is 9 divided by 1? That gives us 9. So for the first case here, we know that 3y multiplied by 2y multiplied by 1/6 of y will give us y cubed. And for the second case here, we know that 45a divided by 5a will give us 9 as the simplest term. Another thing that you need to bear in mind when multiplying or dividing algebraic expressions with similar terms is that the sign also matters, whether it is positive or negative. Now there's something you need to know. The negative sign multiplied by the negative sign will give you a positive sign. Similarly, a positive sign multiplied by a positive sign will give you a positive sign. But when the signs are different, say a negative sign multiplied by a positive sign, it will be negative. And in like manner, a positive sign multiplied by a negative sign will give you a negative answer. And all of this also work if I change the multiplication sign to division sign. So minus divided by minus would give me plus. Okay? And then plus divided by plus would give me plus. Minus divided by plus would give me minus. And then plus divided by minus will give me minus as well. So please put this somewhere so you do not forget. Now let's see it in practice. We are asked to simplify negative 6y multiplied by negative 3y. And then the B part, negative 2m multiplied by 5m, all divided by 3m multiplied by negative 10. So let's simplify them. Solution. Minus 6y multiplied by minus 3y. We multiply the coefficients, so minus 6 multiplied by minus 3. And then y multiplied by y. So minus times minus will give you plus. Is that not so? So 6 times 3 is 18. This is how you write plus 18. You don't have to put the sign there. It is still positive. And then y times y will give you what? Y squared. So minus 6y times minus 3y will give you 18y squared. Now here, what do we have? We have minus 2m multiplied by 5m divided by 3m multiplied by minus 10. So what does this mean? It means we have minus 2 multiplied by 5 divided by 3 multiplied by minus 10. All of this multiplied by m times m, all divided by m. Okay? So what do we have here? This would give us minus 10 divided by minus 30. All of this. Now m here 1, m here 1, so we are left to just m. Now what does this mean? Minus times minus is plus. And 10 goes here once, 10 goes here 3, so we have 1 over 3. Because minus times minus is positive, so 1 over 3 of m. I hope that's clear. So do not forget, minus times minus is plus, minus divided by minus is also plus. The same thing applies to plus times plus and plus divided by plus. But when the signs are different, then you always get a negative answer. Let's take a look at these terms and let's simplify them. So we have 80 STR divided by negative 4S. Okay, so the solution would be, remember we are simplifying 80 STR divided by negative 4S. So for the coefficients, we have 80 divided by negative 4. Okay? And then for the terms, we have STR divided by S. Now take a look at this. S goes here once, S goes here once, 4 goes here once, 4 goes here 20 times. And this is positive, this is negative. So what happens when you have plus divided by minus? That gives you minus. So we have minus 20 divided by 1, which is minus 20, multiplied by TR, so negative 20 TR. It's as simple as that. Now, the next one, we have negative 9AB multiplied by 5B. So it means we're having negative 9 multiplied by 5. And then we have AB multiplied by B. So what does this mean? Negative 9 times 5 will give you negative 45. And then AB times B will give you A. Then B times B is what? B squared. So finally we have minus 45 AB squared. So all you have to look out for is the coefficients and the terms. And don't forget that minus times minus is plus, plus times minus is minus, minus times plus is minus, and plus times plus is also plus. And that's basically how we do multiplication and division of algebraic expressions with similar terms. Now, before we end our study on simplifying algebraic expressions, let us now learn what happens when you have brackets in your expressions. How do you open brackets in expressions, and what does brackets really imply? In line with what we've learned concerning application of order to our algebraic terms. So when it comes to BODMAS, bracket, order, division, multiplication, addition, and subtraction, how do we follow that when we have them involved in the same algebraic expression? So let's get to that. Before we can go into simplifying algebraic expressions that involve brackets, multiplication, division, and all of that combined, there's just one more aspect of simplification that is very important that we teach ourselves about. And that is that you could have similar terms or different terms in the same expressions, and when you're asked to simplify them, you have to arrange them based on their grouping. Now, at the beginning of this video, I did mention something, that if you were told to go clean your room, and then you get to your room, you will see that in your room you have your clothes scattered about, you have books scattered about, you have toys scattered about, amongst other things. So what you want to do to make your room clean is to reorganize it. Okay? That reorganization will involve you putting clean clothes in the wardrobe, right? The dirty ones, what do you do to them? You put them in the laundry baskets. Okay? Now, what do you do to your toys? You put them into a container that houses all your toys. Okay? You take your books, you arrange them on your shelf properly. You put your bed lamp, put it on where it should be, switch it off if it is on, amongst other things that you do. Then you take your broom and then you sweep. Then you dust your bed before you do that, of course. Arrange your bed, make sure everything is in the right position. That's the key word there. You put everything to their right position and then you go on to clean. Okay, so the same thing happens to algebraic expressions, and when you see them, they can look a lot messy. Okay, so what you want to do is to first put everything in their rightful positions, and then you go on to do what? To clean. Just like you do in your room. You put everything where they ought to be first, then you go on to clean. So the same thing with algebraic expressions. You rearrange, collect like terms together, and then you go on to simplify. Quite simple. Now let's take a look at these examples here and do the same principle to them. So here we have, to simplify, 3a plus 4b plus 7b. Now when you look at this, you see we have a, we have b's, 4b and 7b. They are already grouped close to each other. So in order to solve this, what do we do? Solution: 3a plus 4b plus 7b. So they are already grouped. So we tidy this up. This remains 3a. Now to tidy this up, it means we're going to say plus 4 plus 7. That gives you what? 11. Now when you have the similar terms like this, that is terms that are not the same, you cannot add them together. You can multiply, you can divide, but you cannot add or subtract them. So we always leave it like this. So it means 3a plus 4b plus 7b is 3a plus 11b. Now let's look at the second one here. We have 4x plus 7y minus 2x plus y. The first thing you want to do is what? Collect like terms. You might see this in some textbook as just CLT. That's an acronym that stands for collect like terms. Now, what does this mean? It means all the x will be put side by side and all the y side by side. But at the same time, remember that addition comes before subtraction. And if there is multiplication or division, those ones also come before you have addition or subtraction. So since here we only have plus and minus, what do? We're going to just arrange the x and the y's. So for the x, we have plus 4x. If there's any other plus a term of x, we're going to write that. But if there's no other, we go next to the minus 2x. Okay? Now, we go to the y's. So we have plus 7y and then plus y. What does this mean? We'll deal with this separately. That is 4 minus 2 terms of x plus 7 plus 1 terms of y. Now this will give you what? 2x plus 8y. So this is the simplest possible term for this expression. And then finally to C, we have 3a minus 2b minus a. And when we rearrange, collect like terms, that will be 3a minus a minus 2b. This is 3, this is 1. 3 minus 1, that gives us 2a. And then minus 2b. And this is the simplest term for this expression as well. To further cement our understanding on simplifying our algebraic expressions that have multiple terms like this, let's take a look at more examples. This expression states 2a plus 5y minus 2a minus 3y. And then the second one says 3abc plus 6bc plus 7c minus 4bc minus 2c. So let's simplify them. Let's rewrite this. So we have 2a plus 5y minus 2a minus 3y. So what do we do first? Yes, collect like terms. So when we collect like terms, we have 2a, and then this is another a, that's minus 2a. Now we have plus 5y minus 3y. Now what is 2a minus 2a? That is 0. Plus 5y minus 3y. That will give us plus 2y. 5y minus 3y is 2y. So 0 plus 2y, our final answer is 2y. That's the simplest term for this expression. Now we go to B. B is a little bit chaotic, so don't forget, you have to sort them out first. Just like you do with your room. You sort your clothes, you sort your books, you sort everything, your toys and other things that are lying around in order to clean the room. So let's sort this. First, let's rewrite it. We have 3abc plus 6bc plus 7c minus 4bc minus 2c. Now here's the thing. When it comes to sorting like this, do not forget ABC and BC are not the same thing. They are not the same term. They are different from each other. So what do? We look at 3abc first. Do we have any other term of ABC? This is BC, this is C, this is BC, and this is C. No ABC, so this stops for ABC. Now we go to the next one, which is BC. So we have plus 6BC. Which other BC do we have? This is the next BC, so minus 4BC. And then finally we have the C's. Remember, plus comes before minus, so plus 7C and then minus 2C. So 3 ABCs standing all by itself, so we leave it as that. But here 6BC and 4BC, they are the same term, but we have the minus sign between them. So we say 6 minus 4, and that gives us positive 2BC. And then 7C minus 2C will give us plus 5C. And this is the simplest term for this expression. Don't make the mistake of adding these two or these three together. They are not the same term. I hope that's clear. Let's try to simplify these ones as well. I would implore you at this point to try to do it yourself first before you then compare what we do in this video. So how you can achieve this is to pause the video, try it yourself, play back the video and see if you got the answer correctly. And we are very interested to see how well you do with simplifying this expression. So leave us a comment to let us know if you were able to get the correct answer. Alright, so you can go ahead and pause the video now and then try to simplify these expressions. If you have been able to simplify it, this is what your answer should look like. Starting with the first expression, we have 4a plus 12 plus 6a plus 7abc minus 5 minus 3a minus 4abc. So what do? We arrange, collect like terms. This is a very messy room, so let us sort everything and put them in the right place. So starting with a's, terms of a's, we have 4a. We also have 6a and minus 3a. But plus comes before minus, so we have to write this. So plus 6a, then minus 3a. Now, that's all terms of a. We also have terms of ABC. So we go to those. Here we have plus 7abc and minus 4abc. And then we have just constants, numbers that stand by themselves. So we have plus 12 and then minus 5. Now we simplify. This will give you 10a minus 3a plus 7abc minus 4abc plus 12 minus 5. 10 minus 3, that's 7, so 7a. 7 minus 4, that's positive answer, so that will be plus 3abc. And then 12 minus 5, that's plus 7. You can always rearrange this, there's no crime. Your answer could also be 3abc plus 7a plus 7. It could also be 7 plus 7a plus 3abc. They are still the same thing. I just like arranging this way instead, okay? So it's just a thing of preference. They still mean the same thing. So I hope this is what you got as well. And then for the B part, we have 3m plus 6n minus 2r plus 5m plus 3r minus 2n. So let's start with m. So we have 3m here. The next m we have is a positive m, so plus 5m. Now let's go to n. For n, we have plus 6n and then minus 2n. And then for r, you see we have negative 2r before plus 3r. But in the proper arrangement, you should have plus before minus. So we say plus 3r, then minus 2r. The entire thing is to make sure that all terms are where they should be. Then you can always rearrange by positive, negative, or according to the order of BODMAS. So what do we then have next? We have 3m plus 8m plus 5m rather to give us 8m. And then 6n minus 2n, that will give us plus 4n. And then plus 3r minus 2r, that will give us just 1r, so plus r. and this will be the simplest term of this entire expression. Please leave us a comment if you got these answers correctly. And if you did not, do not despair. We are always here for you. All you need to do is let us know where your calculation or where your simplification went wrong, and we'll be more than happy to explain that aspect to you so that you too can learn better how to simplify algebraic expressions like this. Here is another expression, and it's time to simplify it. So the first expression is q plus u plus e plus n plus e minus 2u minus 3n. Now what do we do here? We collect like terms. Now it does not mean you have to arrange them alphabetically. I have to stress this. It does not mean you have to arrange them alphabetically. Okay? All you have to do is put those who are similar close to each other and you simplify from there. So if I'm starting from Q, I start with Q and say Q. Do I have any other Q? No. So I go to the next letter I want to move on to. So if I'm moving to U next, it will be plus U. Then I look for the next U. This is it, and that's minus 2U. Remember, if there's a plus U again, I have to put that before the minus U. Now let's go to E. So we have plus E. And then to N, we have plus N minus 3N. And that's it. So what do we have here? It's just Q. Now, U minus 2U. That's like saying 1 minus 2. That gives you negative 1. So minus U. Let me come again. U minus 2U. This is 1 minus 2. And that gives you negative 1. Whenever you have something like this, a small number minus a large number, your answer will be negative. And negative of, you now perform 2 minus 1, and that gives you 1. So negative 1. That's why it's negative U. Negative 1U. Okay? Now, we move to E. E plus E, that is 2E. So plus 2E. And then N minus 3N. That gives us what? Negative 2N. How is that so? This is 1N, this is 3N, and it's negative 3N. So our answer is definitely going to be minus. So we say 3 minus 1, and that's 2. So minus 2N. So it looks like we have QUEEN, queen, right? But with the plus 2 and negative 2 attached to E and N. Okay? This is the simplest term here. Now we go to the next one. 3 minus 4x plus 5y plus 9z minus 6 plus 5x minus 3y plus 2z. So once again, it does not matter whether you are arranging alphabetically. All you need to do is ensure that you collect all the like terms. So let's collect them. Starting with the numbers, so we have 3 here. The next number that stands on its own is 6, and it's minus 6. Now we go to x. This is minus 4x. I'm not going to start with minus 4x. I'll go to the plus x. And the plus x I have here is this. So I'll say plus 5x. Now please take note. If the only x I have here is this minus 4x, I will write it just like that. So but because I have the positive one, I'll write that first because I have to follow BODMAS. So plus 5x minus 4x. Now I go to y. So plus 5y minus 3y. And then to z, plus 9z plus 2z. Okay? So now let's simplify. 3 minus 6. Of course, the negative one is larger, so our answer there will be minus. So 6 minus 3, that's 3. So minus 3. Then here will give us what? Plus x. This will give us plus 2y. And then this one will give us what? Plus 11z. Now, I don't like writing my simplified terms with a negative sign starting it. So instead, I'll rearrange and I'll say x plus 2y plus 11z then minus 3. Okay? So this is the simplest term for this expression as well. And with that done, we've been able to look at simplification of algebraic expression as contained in the syllabus for week 3. Now, this topic continues in week 4, and there we will be looking at first simplifying algebraic expressions that involves brackets. And then we close all of it by looking at what problems involving the simplification of algebraic expressions. So you don't want to miss that lesson. So if you don't want to miss that lesson, ensure that you are subscribed to the channel and also click the notification bell icon so that you get notified once the video is uploaded. Please do not forget to share the video so that you can be helping other students like you to get better in their academics when they get access to Oyalearn, your flawless school tool. And if you do have any question at all, please interact with us. The comment section is open to everyone. Whether you have a question or whether you have a commendation, if there's something you want to tell us, keep them coming. Just drop them in the comment section and we'll definitely attend to all of your comments. With this, we've come to the end of week 3 of JSS1 second term mathematics. There's still many more coming your way, and I look forward to having you in the next video. Bye for now.